Hi, good morning, and welcome to the FoodSense webinar. So we do this webinar every Wednesday. We meant to do it at approximately 8 a.m. London time, but we have gone late today, and that's because we had a sort of an interesting question that came in over the night, and I basically sort of delayed slightly to answer that question. I might be slightly shouting into this mic this morning, and it's because I've got a 3D printer running in the background, but I think the noise is more apparent to me than it is to you. But let me go forward a little bit and say today's I say here the 31st of February. Goodness, I'm getting confused myself as to what. No, it's the 31st of January. So my apologies for that. But today's the 31st of January. Let me go forward and just say, look, we do this webinar every week, and it's about rapid tests, digitization, and traceability in the supply chain. This is pertinent because today, actually, one of the questions is about food testing. They're at the moment doing organoleptic testing. They actually do want to digitize it, and this is really what ZP's FoodSense is all about, is actually digitizing some of these ingredients testing in the supply chain. I'd also describe it as very transparent. And what I mean by that is we're having a discussion at the moment with somebody who's very interested in measuring hot peppers. Today I'll have done a literature review on Carolina Reapers, and I mean Carolina Reaper powders. But the nice thing about the technology is that we have, it's at least transparent, that when we say what a number is, we can actually go back and look at the raw data. So it's very kind of, if you do organoleptic testing, there's really no sort of, that's a very subjective way of assessing the hotness of products. If you do HPLC, you get a sort of certificate of analysis, but you've no real sense of the quality control behind that. That said, I'll go forward with our webinar today. So I will be talking about food samples. This came in from Asia overnight, and I will address that. I do want to talk about the distribution of Carolina Reaper powder hotnesses. So I did do a literature review. A literature review means, I've literally read the scientific papers, found out all the different results, and did a bit of a meta-analysis, we call it, on looking at the scientific papers. Just want to talk about the distribution of hotness within a Carolina Reaper. Carolina Reapers, the capsaicin is not evenly distributed throughout the product. Something that happens a lot, I think, is people have an expectation on their product, and you get a certificate of analysis from the supplier. Maybe you don't have it. Maybe you just have a website reference. But that said, how you store that powder is obvious to the to the professional sort of companies out there, but how you store that powder really is a factor on the hotness or the Scoville heat unit that you will measure, and I will touch upon that. At ZP, we have actually validated against HPLC, and I will reference that as well. But it's also worth saying on the HPLC front, many of these HPLC tests are using what's called an AOAC method, and I think it's 99.5.03 or something along those lines, and that actually tops out at 750,000 Scoville heat units. So be careful about HPLC results, because depending on the methodology they're using, it may not be validated for the super hot sort of 2.2 million Carolina Reaper powders. But I'll go into that during the webinar today. Just to say, if you're interested in FoodSense Generation 4, this is an objective, quick, transparent way of measuring the Scoville heat unit of powders and sauces. You'll see that happen today, or you'll see, at least I'll discuss it. Come to a live demo on the 28th of February 2024. There will be a live demo, and we do one in the morning and one in the afternoon, and it's really just to give you the opportunity to attend live. We'd like to do them live because that way you can see the robustness of the technology, and you can see it running in, let's say, in real time. So 2 webinars, 28th of February, they're free. Apologies earlier on for saying today was the 31st of February. It's not. It's A, that date doesn't exist, and B, it's the 31st of January. So we are about objective digitization and testing in the food ingredients market. I am specifically talking about Scoville heat units today. The reason it's important is because what does Scoville heat unit actually mean? What does it really mean? So Wilbur Scoville, 1912, came up with an organoleptic test. So what he's effectively saying is, right, you take a panel of people, let's say you take 5 people, and you give them something to taste, and then you dilute it, and then you give it to them to taste again, and you ask the question, can you still taste it? And all 5 people say, yes, I can still taste that. Okay, so you go, okay, what I'm going to do is I'm going to dilute it again. So I'll take dilutant 1 and I'll dilute it again, so get dilutant 2, and I ask these 5 people, can you still taste the hotness? And actually one of them says, no, I can't. So now I've got a panel of 4 people. And then I take dilutant 2 and I dilute it again to dilutant 3, and I ask the panel, the remaining panel, can you still taste it? And 3 of them say, yeah, I can still taste it. So I take dilutant 3 and I dilute it to dilutant 4, and I ask them, can you taste it? And 2 of them say, yeah, I can still taste it. But 3 of them have dropped out at this point. So once I've had 3 of them, or 60% of these people, drop out, that is my Scoville heat unit. And from there I can calculate my Scoville heat unit by going dilutant 1 times dilutant 2 times dilutant 3 times dilutant 4 gives my Scoville heat unit. Now what does that mean then? So I'll give you, sort of put some numbers behind that. So for example, if I dilute it by 10x in the first instance, and then another 10x, and then another 10x, and then another 10x, then my Scoville heat unit here is 10,000 or 10,000 Scoville heat units, SHUs. Nobody does this because it takes 5 people. These 5 people better be consistent if you want to do batch to batch, different batch releases. And, you have to do quite a lot of work in order to kind of come down to where 3 people have agreed that they can no longer taste it, and therefore you can calculate the Scoville heat unit. So that was what Wilbur Scoville did in 1912, and that's where the units SHU actually come from. Now obviously we want to do this in a much faster, lower cost, more transparent, objective manner, and digitize it, and that's really what the FoodSense Generation 4 is all about. I mean, just out of interest, just to give some examples, so Tabasco sauce advertises itself at being 2,000 to 5,500 Scoville heat units. That realistic, and we measure that all the time. But realistically, that means you're taking 1 milliliter of Tabasco sauce, and you're probably dissolving it in something like 2.5 to 5 liters of sugar water until you can no longer taste it. So that's literally what the Scoville heat unit means for Tabasco sauce. When we're talking about things like Carolina Reaper, that's got a reputation for being 2.2 million. As I say, I've got some quite a lot of work I've done over the last few days about what I call a meta study on this. But Carolina Reaper is advertised at being 2.2 million Scoville heat units. What does that mean? It means if I took 1 gram of Carolina Reaper and put it in 2,200 liters, I'll put that into gallons as well, so that's 484 gallons, then I should not be able to taste that pepper, because that's basically doing a 1 in sort of 2.2 million dilution. Now what does 2,000 liters or 484 gallons look like? This is a pallet, and you see these sometimes in facilities where they have these big containers on pallets. That is 1,000 liters, and so you need to take 1 gram rather of Carolina Reaper, dissolve it in 2 of these in order to actually achieve a dilution of 2.2 million, and therefore record 2.2 million Scoville heat units. So you can see the massive dilution it's required to otherwise lose the Carolina Reaper. Realistically, you can't do this kind of organoleptic testing. It's so, almost manual and hard work to actually do this. This is why you need an objective system, and that's what the FoodSense is. I'm particularly these days referring to the FoodSense Generation 4 because it's really about transparency. And what I mean by that is that when we say what a number is, we're actually able to look online and see the raw data behind that number. So this is the FoodSense Generation 4. It has little sensors. This is one of our engineers, and she's making a Bluetooth connection to that device. And it's really important because she makes a Bluetooth connection to it. She'll get a result on her phone, but she will also, in this video, she also reports that the fact is the data also goes to the cloud as well. This is also to say that the FoodSense Generation 4 today is actually multi-analyte, that we use these series of QR codes and we can go from analyte to analyte pretty effortlessly. And that's what the little unit looks like, just FYI. Now, I know this is probably recorded, so you could probably pause it at this point and just say if you're ever interested in getting hold of the software, I don't want to say useless to you, unless you've got the hardware, the software is essentially useless to you, but you can see that we've We've got it available on the Google Play, and we've also got it available on the Apple App Store as well. And I keep needing to repair that double R install. And then when you do install the app, you will find that you can scan QR codes and you can move to different analytes. So it's a sort of multi-analyte system, which really helps understand, the value for money of this system. The way the system actually works is we have sensors, we have the meter, we have the apps. You can install the app using those QR codes earlier on. The app will then run a Chilli sensor, for example, if you scan the QR code for Chilli. Now what happens is you put the sensor into the meter, you put the sample on the sensor, the app runs the meter, the meter gives the data back to the app, and the app actually sends the data to the cloud. So you on your phone will get Scoville heat units, and I'll discuss that a bit today, that people are getting Scoville heat units on their phone. But this is a really important bit as well, is that there's actually the quality, traceability, digitization, if I can use all these, sort of throw those words in there, because what it really does is it sends the whole raw data to the cloud, so we can always troubleshoot or see what's really going on. It's like a sort of, sometimes in science you have spectrometers which kind of record how light is absorbed by materials. It's essentially like a spectrum, but it's the electrochemical equivalent of a spectrum. And what's really cool is that you can actually share that with people like ZP as well. So you don't have to, it's protected by a username and password, but on the FoodSense Generation 4, it does allow us to actually look at the data and helps to troubleshoot quite a bit. So today I'm going to troubleshoot somebody's testing, but they're on a previous generation, but I'm going to sort of just use experience to try and explain what's going on. But if it was a FoodSense Generation 4, I wouldn't be sort of speculating so much. I'd actually be looking at the raw data as well. It's probably worth saying it's got an API, so it will plug into what's called laboratory management systems, information management systems. Just to talk about support, everyone gets personal online training. We're always very consistent with this, so everyone gets personal online training. We do weekly webinars, so I do get questions in. A question arrived last night. I thought it's important enough that I'll answer it this morning. And we do monthly webinars, so the 28th of February, there will be that monthly webinar. Please sign up. Please come along to that. So questions today, testing food samples. I will talk about testing some food samples. This was overnight questions. I will talk about the distribution of hotness, or let's say capsaicin, among chili powders. This is looking at the literature. Distribution of hotness within a Carolina Reaper. I found a paper on that. I will talk about the storage conditions, because I'm mostly concerned that actually people are really holding on to, well, this must be this hotness. But they're not thinking, actually, how long have I had this powder for? How have I stored this powder? These are important factors. And then our validation by HPLC. So question number 1 is about testing food. It's a problem statement. So there's a manufacturer. They're making spicy foods. They've got complaints that their products are too spicy. And they want a database control of their spiciness with Chilli sensor. Yeah, so they want an objective, traceable evidence that what they're shipping is actually within specification. And this, to be frank, is the case that we were when we were first imagining this. We were kind of of this thought that you want to be able to not defend, but you want to be able to sort of say, the reason that I think my product is what it is because I've got some objective way of doing it. That's exactly what we were trying to do it for. So rapid test, digitization, and traceability in the supply chain is what FoodSense is actually all about. So at the moment, I say here, they are doing an organoleptic testing. So they're not necessarily doing any objective testing. They may be occasionally testing by high-pressure liquid chromatography, or sometimes people shorten to liquid chromatography. But they're not doing a lot of it because it's probably expensive and it takes too long. They are borrowing a pre-Gen 4 FoodSense at the moment. So they've been doing some work with a pre-Gen 4 FoodSense, so I will touch upon that. The reason it's important is because with the Gen 4 product, actually all the raw data, and I will show that in a minute, with that it all goes to the cloud, and therefore it would be much easier to be able to support in this case. So they've got some samples. One of them, which is a powdered red pepper. They've got a sauce. It's not Tabasco. They've got some sort of spicy sauce, and then they've got a sauce plus dried fish. So I will describe this and go through this now as well. So they get a result. For example, I think they're taking this powdered red chili and they're diluting it, and they say by a 9x. So I suspect it's what I would call a kind of 1 plus 9 is a 1 in 10 dilution. So I suspect they're doing something like 1 milliliter plus 9 millimeters of buffer. I would call it a 1 in 10 dilution, or 1 gram in 9 milliliters of buffer. I'd call it a 1 in 10. But I get the point. It doesn't make a big difference. They're doing this and they're getting approximately 3,665, and then they're testing. It's either the same sample or a different sample, and they get 3,405. Now they think there's a significant difference here, that it's different by about 260. The fact is, I think part of when I say we do weekly webinars, we do, when these kind of questions come in, then we do help people to sometimes understand these numbers, because test 1 came in at 3,665, test 2 came in at 3,405. The average of these two is 3,535. The standard deviation of those two numbers. Now, standard deviation on only two numbers, it's not very good statistical practice, let's say. You need a few more tests, but I think it makes the point a little bit that the standard deviation here is 184. Now, relative standard deviation is a nice way of saying I've got a bunch of numbers. How close are these numbers all to one another? And so the relative standard deviation, or the difference between these numbers, is standard deviation divided by average is 5.2%. Immediately it makes you think these two numbers are not different numbers. They're actually the same number. Now, I know, because the difference between them is like 265, but that's relative to values of like 3,500, so it's actually relatively very small difference. If I took the average and add two standard deviations, so that means the average is 3,535 plus 2 times 184. I have an upper range of 3,903 and a lower range of 3,167. So what I would be saying about this product is, from this data, it's actually got a Scoville heat unit of 3,535, and I would sort of be saying, plus or minus 5.2%, or I could use these ranges as well. This number is precise in terms of it's repeatable, but it's not accurate, and I'll describe why I think it's not accurate in a minute. And I suppose I should have said, well, I'll dive into that now. So I think the number is precise. They're very close to each other, but I don't consider the number accurate. And the reason I believe that it's precise is because these two numbers are not different. They're actually the same result. Now let me try and describe why I don't think it's accurate. So Scoville capsaicin is not terribly soluble. In fact, capsaicin is just experience now, and also reading the literature and doing quite a lot of tests over the years, that we realize that capsaicin is probably in it. What makes things hot is capsaicin will solubilize in fats, capsaicin will solubilize in oils, but it's not very soluble in waters, in liquids. So in fact, it's actually quite insoluble. So it only dissolves to about 500 Scoville heat units. When you cook it up with other things like oils and fats, that helps to solubilize it. But in this case, I think these people have done they've done a 1, and I think it's approximately in 10 dilution, but actually it's saturated. So we've got this rule of about, I think that capsaicin only dissolves to about 500 Scoville heat units. So I think they've under diluted. So we say to people, if you've got something very mild, then these days we say do a 1 in 10 dilution. And if you've got something a bit hotter, then you probably have to increase that volume and do a 1 in 100 dilution. Now on the new FoodSense Generation 4, it actually says, are you going to do a 1 in 10 dilution, or 1 in 100 dilution, or 1 in 1000 dilution? So this kind of arbitrary what dilution do I use has gone away. We've reduced those factors so that people are sort of are much more guided, let's say. But I have a bit of a rule. I sort of call it the 500 rule. If you think your sample is 0 to 5,000, then do a 1 in 10 dilution. It doesn't matter on the FoodSense Generation 4. It will demand that you do a 1 in 10 dilution. If we think it's something like 5,000 to 50,000, we'll tell you to do a 1 in 100 dilution. If we think it's higher than that, we'll tell you to do a 1 in 1000 dilution. So what we're doing is we're sort of asking, well, do you think it's particularly hot? And then we're diluting accordingly. You might say, well, how do I know? Because I don't know. It's unknown. Well, actually, because all the data goes to the cloud, we can see it when the solution is saturated. So if you do a test, and so experience would tell me that the first results that they've got here, they've got this like very consistent 3,600 results. They've done it 1 in 10. They're very consistent. I think it's saturated. If I had their raw data, I could tell them it was saturated. But that's but because it's a pre-FoodSense Generation 4, I can't. But I would tell them to do a 1 in 100 dilution on that sample. But these days the FoodSense Generation 4 really guides that kind of experience, so that it's less, people are less. When I say, with FoodSense Generation 4, literally the data goes to the cloud, so we can actually go up there and look at the raw signal. I'm not trying to make people be, electroanalytical chemists. I'm just saying there's this option that actually people like ZP can help support people, and I'm supporting people in India and I'm supporting people in the US because they're on FoodSense Generation 4. If they ask us, do you think this is working okay, when we can look at the data and that kind of works. In fact, I may even, let me just show you. So this is Julie. So this is some data. See, so this is data that's gathered. I can see when the data was gathered. I can see the operator. I can see the notes behind it. They were making 2.5 million Scoville heat units and 6 million and 9 million Scoville heat unit measurements. You may ask why. There's people out there that things like Carolina Reaper are like 2.2 million. So you want to be able to measure 2.5 million. But it's also interesting because there are people out there that are making, weaponizing, capsaicin, let's say, and there they could go extremely hot. So, but the reason I bring this up is because there's a real transparency to it, that every time a test happens, it immediately goes to the cloud. I'm logging in with my username and password. I won't be able to see your data unless you share it with me, but I just want you to know that actually it does go up there. And here I'm looking at some extremely hot capsaicin results. As I say, 2.5, 6.4, 9 million Scoville heat units. So that's why FoodSense Generation 4 is so good. So they've got these red peppers. I think they're doing I think they reported a 1 in 10 dilution. Well, they call it 1 in 9, but I think it's approximately 1 in 10. I think it's saturated. I think you need to do a 1 in 100 dilution. If you're on FoodSense Generation 4, I'll be able to tell you because I'll be able to see the raw signals. But I think not being able to see the raw signals, my best guess is you need to do a 1 in 100 dilution to actually... so your results are precise, but because of saturation, they're not accurate. We do have a lot of people testing chili powders. I've got some people testing them at 1 in 100 because they're more mild, and I've got some people testing 1 in 1000 because they're actually hotter. But it's only when they've done a few tests and I can see the raw data that I can actually make that kind of comparison. It's like I say, it's just worth knowing that this is the result on the phone. That in this case they got 55,679 Scoville heat units, and we're able to say that everything's okay because actually the data went to the cloud and we're able to see it up in that cloud. So that is an important aspect of FoodSense Generation 4. In this case, they tested the same sample several times. They got their average. They got their standard deviation. I should have called this relative standard deviation here of 18%. So I understand. So it is. They've done the tests. They've done it 5 times. We've got the statistical numbers behind this, and that is, it's all logged and let's say saved. Now, the same person who came in with questions overnight to me has also been doing some other sources. And here they've done a 1 in 4 dilution. And I sort of understand why they do this, because when we first started, we were also saying, oh yeah, test do a 1 in 4 dilution. So I know why they did it. I suppose we've just, now we're on FoodSense Generation 4. We are, several sort of, iterations in at this point. So I've got a suspicion this 828 and this 881. I did a similar analysis and said, okay, test 1 is 828 Scoville heat units. Test 2 is 881 Scoville units. The average of these two is 855 Scoville units. The standard deviation is actually really small, 37. Relative standard deviation is 4.4%. So I really have a suspicion these two numbers are actually the same. I think they're possibly... Well, what am I thinking here? I suppose, first of all, I want them to do a 1 in 10 dilution. I've got a feeling that actually these numbers are probably accurate and precise. But really, it's coming back and telling me that these two things are probably the same hotness. The nice thing is, see, because if they do some testing on FoodSense Generation 4, I will be able to see the results. So anything that's sort of, this is a more complex thing. They got dried fish in here, for example. So, sometimes seeing the raw signal can really help. But I suspect that if they were on FoodSense Generation 4, first of all, the machine would make them do a 1 in 10 dilution. And then it would be really helpful to me to be able to see the raw signal. I'm slightly changing direction now, because this was the original webinar I was going to give, but what I just covered was questions that came in overnight. But the original webinar is, we've got some people who are very interested in testing hot powders. And I wanted to go through the literature, actually, and the literature is important because, I'm a commercial guy, so, commercial people like us, we're not, we're not so independent. But I went to the actual literature and said, okay, so who's measured Carolina Reaper and who's actually reported it in the scientific literature? The thing about the scientific literature is that it is peer reviewed. It is kind of, held to a certain standard that, people should have independently looked at the data. So looking at the literature, I find results for 3 million Scoville heat units for Carolina Reaper. I find 2.2 million Scoville heat units. I find 500,000 Scoville heat units. I find about 1.6-ish. I find about 1.7 million Scoville heat units. And I find 1 million Scoville heat units. So first of all, Carolina Reaper powders and Carolina Reapers, there is a range of hotnesses in the literature. I understand the world record is, was for Carolina Reaper about 2.2 million. So I do understand all of that. But depending on the source, it doesn't always come back. Sometimes it comes back hotter and sometimes it comes back milder. So just be careful when you have this generic idea that Carolina Reaper is 2.2 million. The literature, which is independent of me, and I'm going to put all my references up in the next few slides, says on average it may be 1.7 million. It's got quite a high standard deviation across all those results. And that relative standard deviation is about 51%. So don't necessarily just take it that all Carolina Reaper powders and Carolina Reapers are 2.2 million. So I said I put my, if I've got the link, I put the link up there, but I just want you to give, the title, the author, and actually, whoops-a-daisy. And actually, I did find the, let's say, the results in those papers. So every time I find a number, I report it so I can see that's the 534,000 Scoville heat units. Carolina Reaper, and I can see 1.7, just below 1.8 here, million, that is Scoville heat units, and also here the 1 million. So just to say that and this is literature, independent researchers who are peer reviewed, they're not all 2.2 million, just know that. And that's where I get this table from. So I've took those papers, took quite a few hours to find all those different papers, to check find the result, report the result, do all the statistics on it. So it's a little bit of effort has gone into this, and that's where I come up with my results. So not all Scoville heat units, not all Carolina Reapers are the same. So just FYI. It's also, when I was doing this work as well, I thought it was kind of interesting actually that that somebody looked at the pepper itself and said, look, that we've got the placenta and we've got the pericarp and the whole fruit here. And what they said was 2.3 million Scoville units can be found in the placenta. 2 million pericarp can be found in the, 2 million Scoville units can be found in the pericarp. On an average, the pepper yields about 1.7 million Scoville units. So I just want to say that this is a very heterogeneous product. So the pepper itself was heterogeneous, and so when you take pepper to pepper, there's a variation. Within a pepper, there's a variation, and I can absolutely assure you from season to season and from region to region, there's differences. So be careful with this whole mindset that Carolina Reapers are 2.2 million. So on average, the distribution of the relative standard deviation of, if you sample a pepper, you may find, quite a lot of variability just within one pepper. That's what I want to say. I also want to say, look, if you've got chili powders, take a look at them underneath a microscope, because you're going to find out that it's very heterogeneous. So it's like, you've got to really sample chili powders a lot in order to build up a statistically significant understanding of the average of that chili powder, because a little bit of microscopy, you'll see that there's a white piece here, there's a black piece here, there's a dark red piece. I suppose there's mostly bulk light red pieces here, but that is not a homogeneous sample. It's a very heterogeneous sample. So be careful when thinking about Carolina Reaper or Carolina Reaper powders rather. They're very heterogeneous. I mean, I've talked about this in the past, but when you've got something that's very, so for your sample here, if I've got something that's very heterogeneous, depending on where I sample within this, let's say, sample, if I sample here, then I get one capsaicin molecule. And if I sample here, I get two capsaicin molecules. So it's not unrealistic to actually say that what's happening in the world of Carolina Reaper powder testing is that people are not doing enough testing in order to get an accurate enough average result for the powder. If it was more homogeneous like this, then you kind of where you sample doesn't matter so much. But it's an assumption that actually the powders are homogeneous. So in one case, if it's highly heterogeneous, you can actually end up with relative standard deviations of 141%. And if it's more homogeneous, you can end up with relative standard deviations of 43%. The more tests you do and the more averaging you do, then the more accurate your actual result. But accuracy in part comes from the equipment, but it also in part comes from the heterogeneity of the sample. So we do have people who do test a lot. They do it very systematically. And I would expect them to sort of, maybe they would have tested the powder 5 times and they may end up with a relative standard deviation of 18%. I always think that, well, the rule of thumb is that if you get a relative standard deviation better than 20%, then you've got a useful test. And if it's better in a sort of natural product like this, then it's, getting below 25% is good as well. This is something that really concerns me is people buy powders, they may test them, but we've got no idea of how much light exposure that powder has had. How much light exposure did that powder have before you received it? How much light exposure has that powder had since you've received it? Temperature. What temperatures was that powder exposed to during production, during storage, during shipping, and then during your, let's say, storage? Humidity. What I mean by that is moisture. I know people try to keep things dry, but a little bit of moisture can end up damaging capsaicin. Capsaicin is an organic molecule. It doesn't like light. It doesn't particularly like temperature. It doesn't particularly like humidity. And it also is able to be oxidized. I think I want to say 16% of the atmosphere is oxygen, so it's quite an oxidizing atmosphere we live in. So air exposure is a problem. How you pack that material, how you store that material is really important. And then it's how you link to that is really the packing material. I suspect that dark, opaque glasses is probably one of the best ways of storing it. Transparent glass and probably worse, transparent plastics is not the best way of storing it because UV light can get through that fairly more readily. Let's say glass is better at screening UV. Plastics, I think UV can get through quite well. And then your duration of storage, how long you've been storing that for. If all these parameters are unknown or uncontrolled, then your capsaicin level is no longer going to be at what you're expected, 2.2 million. It's somewhere below that. Question number D, just out of interest, people are very kind of committed to HPLC testing on some of these things. One of the most, I think, the AOAC method, which is 99.5.03, it's actually only rated to test up to 650,000 Scoville heat units. So just be careful. We have tested against HPLC ourselves, and it's been done independently as well. I'll put those links underneath the webinar at the end. So we do have our own HPLC testing, and we do also have some testing done independently of us by on HPLC. But it's probably worth saying that when people ship like Carolina Reapers and they say 2.2 million, you have to understand what HPLC method they use, because the official one, AOAC, actually tops out at 650,000, oh no, it's actually 750,000 Scoville heat units. No, it was 650,000 Scoville heat units, sorry. So, you know, you do have to, A, see the certificate of analysis, then the method that they're actually using, and then understand that the method may not actually have been validated for that. Obviously, I think that all these problems are solved because the FoodSense Generation 4 is pretty easy to use. It allows you to do rapid testing. It allows you to have a transparency of results that, you know, we'll give you a Scoville heat unit, but also we're able to back it up with the raw data. You know, and I do, if you choose to share that raw data with us, then I can, you know, I do write reports for people, you know, and try to analyze the results. There is a limit to how much reporting we can do. You know, we try to help people get to speed, but there is a point at which, you know, obviously, you know, you can't go forever on this. So question number 1, testing food samples. I've got a suspicion that your powder testing is, I suspect, under diluted. It needs to be probably 1 in 10. And I also would suspect that that sauce also needs to be 1 in 10. The sauce with the fish in it is going to be harder. That's a complex sample. The sauce without the fish in it, we should be able to do that quite well. If you were on a FoodSense Generation 4, I would be able to see the raw data, so I'd really be able to kind of help there. Carolina Reaper got a reputation for being 2.2 million. If you look at the literature results, it actually goes from 3 million to 500,000. That's not my data, and I will, you can watch the video, you can see the titles, you can see the authors of those papers. Carolina Reaper as a pepper has a distribution of hotness within it. And then when you put that with the fact that in different regions, in different papers, they have different results, you've got to understand this is a very heterogeneous sample. And I do put some HPLC data up here as well. So I want to say thank you very much. As I say, we went late today, and it's because the food testing results came in overnight, or the question came in overnight, and I wanted to jump into it. I apologise if there's been a bit of a low drone in the background. As I say, there's HPLC, HPLC. There's a 3D printer running in the background. I couldn't stop the print because it takes hours as it is. So my apologies. But anyway, we do weekly webinars. That's how we support people. We do personalised online training when you first get the results, and we do monthly webinars as well. So if you've got any questions, don't hesitate to reach out to us. Okay, thanks very much.